Hi everyone. Today we're going to study exponential functions. Let us first define exponential function. The equation f of x equals b raised to x defines an exponential function for each different constant b called the base. There is a restriction that the base must be greater than 0. It means b must be positive. Also, b should not be equal to 1. The independent variable x can assume any real value. It means to say, for an exponential function, we expect a variable, which is x, as an exponent. Example 1, f of x equals 2 raised to x. In here, the base is 2 and the exponent is x. Here is a quick look of how the graph of f of x equals 2 raised to x looks like. Another example is f of x equals 1 over 2 raised to x. In this example, the base is 1/2 and again, the exponent is x. Here is a quick look on how the graph looks like. There is a note that the domain of the function is the set of all real numbers r, and this is the interval notation, negative infinity to positive infinity, and the range of f is the set of all positive real numbers, and this is the interval notation from 0 to infinity. Take note, we are using the parentheses for the 0, and 0 is not part of the solution. Let's go now to the graphs of exponential functions. Here are the respective graphs of our example a while ago. The y equals 2 raised to x and the y equals 1/2 raised to x. Let us study the properties of the graphs of exponential functions, and this is the first one. All graphs pass through the point 0, 1. This is the point 0, 1. Number 2 property, all graphs are continuous with no holes or jumps. Property number 3, the x-axis is a horizontal asymptote. Asymptote is a line that the graph is approaching but never intersect. If you notice the graph, it is approaching the x-axis, but it will never intersect the x-axis. Property number 4. If b is greater than 1, then the function b raised to x increases as x increases. This is an example of a graph with b, or the base, is greater than 1. Property number 5. If b is between 0 and 1, then the function b raised to x decreases as x increases. This is an example of a graph for property number 5. Number 6 property, the function f is 1 to 1. Today, we're going to study graphing exponential function of the form f of x equals b raised to x. Here are the 4 general steps. Step 1. Create a table of points. Step 2. Plot at least 3 points from the table, including the y-intercept, which is 0, 1. Step 3. Draw a smooth curve through the points. Step 4. State the domain, that is from negative infinity to positive infinity. The range, and the range is from 0 to infinity. And the horizontal asymptote. The equation of the line is y equals 0. Let us see this example. Sketch the graph of f of x equals 0.25 raised to x. State the domain, range, and asymptote. Let us write the problem down here. Let us go now to step 1. That is to create a table of points. Here is our table. For the x values, we put 0 here and 1, 2, and 3 on the right of 0, while negative 1, negative 2, negative 3 on the left side of 0. So we have here 7 values for x. Use calculator now to find the respective value of f of x. When x is 0, f of x is 1. When x is negative 3, f of x becomes 64. When x is negative 2, f of x is 16. When x is negative 1, f of x is 4. When x is 1, f of x is 0.25. When x is 2, f of x becomes 0.06. When x is 3, f of x is 0.02. For steps 2 and 3, plot at least 3 points from the table, including the y-intercept 0, 1. Draw a smooth curve through the points. Here now is our graph. We plotted 3 points, including the 0, 1, this point negative 1, 4, and another point 1, 0.25. This is now our smooth curve. Step 4. Let us state the domain, the range, and the asymptote. The domain is from negative infinity to positive infinity. The range from 0 to positive infinity. And asymptote is that horizontal line y equals 0. This is now the final answer. Example 2. Sketch the graph of f of x equals 4 times the quantity 1/2 that is raised to x. State the domain, range, and asymptote. Let us write our function here. Then step 1. Let's create a table of points. We have this table. Let us now fill in the corresponding values. We can use calculator here. Let's begin with when x equals 0, we substitute this 0 to the x here, then we will get the value of f of x. So, the f of x when x is 0 is 4. What about when x is 1? F of x is 2. When x is 2, f of x is 1. When x is 3, f of x is 0.5. When x is negative 1, f of x is 8. When x is negative 2, f of x is 16. When x is negative 3, f of x is 32. Now step 2. We plot at least 3 points from this table, including the y-intercept 0, 4. So we choose these 3 points. Then step 3, we draw a smooth curve through the points. So we have the points negative 1, 8, the 0, 4, and the point 1, 2. And this is the smooth curve. This is the graph of the given function. Now step 4, let's take the domain, the range, and the asymptote. For the domain, what are the values for x? We can see that the domain is from negative infinity to positive infinity. Then the range. The range are the values for y. By the graph, we see that the range is from 0 to positive infinity, while the asymptote is the x-axis, and the equation is y equals 0. Today we're going to study natural exponential function. Let us define exponential function with base e. For a real number x, the equation f of x equals e raised to x defines the exponential function with base e. In mathematics, this letter e has a numerical value equal to 2.71828 and so on. And this function here is called natural exponential function. Let us take a quick look of the graph of this f of x equals e raised to x, but in here it is written y equals e raised to x, and they have the same meaning. Now let us learn how to graph natural exponential function. Step 1. Fill in table of values with substantial number of pairs. It means we can have the table of values that looks like this. We have 2 columns. The first column is for the x. We have 5 blanks here that we can write the values 2, 1, 0, negative 1, and negative 2. The second column is for the f of x. And this means we have f of 2 corresponding to the value of x, that is 2, and f of 1 corresponding to the value of x, which is 1, f of 0 corresponding to the value of x, which is 0, f of negative 1 corresponding to the value of x, which is negative 1, and f of negative 2 that corresponds to the value of x as negative 2. And then, step 2, plot the points and connect them with a smooth curve. Let us have an example. Graph the function f of x equals e raised to x. Our step 1 is to fill in table of values with substantial number of pairs. So we have the x with these 5 values. We have the f of x. We have the corresponding f of 2, f of 1, f of 0, f of negative 1, f of negative 2, respectively. So given our function here as e raised to x, we will copy it here. It means to say, when we evaluate f of 2, we will have e squared. For f of 1, we will have e raised to 1. F of 0 equals e raised to 0. F of negative 1 equals e raised to negative 1. And f of negative 2 equals e raised to negative 2. Using our calculator, we will have the values e squared equals 7.39. E raised to 1 equals 2.72. E raised to 0 equals 1. E raised to negative 1 is 0.37. E raised to negative 2 equals 0.14. Let us write another column and put the ordered pairs xy. So we have 2, 7.39. Second point is 1, 2.72. Third point, the 0, 1. Fourth is negative 1, 0.37. Last point is negative 2, 0.14. And then step 2, let us plot the points and connect them with a smooth curve. This is now the curve. Look at our first point, 2, 7.39. It is here. The 1, 2.72 is here. The point 0.1 is here. The point negative 1, 0.37 is here. And the point negative 2, 0.14 is here. And we can see the smooth curve. And this is our final answer. Let us see here the comparison of the graph of f of x equals e raised to x, and the graph is that color blue. The graph f of x equals 2 raised to x is this graph in red, and the graph f of x equals 3 raised to x is the graph in color green. Take note that all these graphs have domain negative infinity, positive infinity. And the range is open parenthesis 0, infinity. Take note, the graph of natural exponential function follows the properties of the graph of exponential function. In this video, we are going to study properties of exponential functions. Let a and b be positives, where a is not equal to 1 and b also not equal to 1, and x and y are real numbers. The first property is about exponent laws. Here are 6 examples of our exponent laws. Property number 1, when we have a raised to x times a raised to y equals a raised to the sum of x and y. Exponent law number 2, a raised to x over a raised to y equals a raised to the difference x minus y. Law number 3, ab raised to x is equal to a raised to x times b raised to x. Law number 4, when we have a quotient and this is raised to x, this is equal to a raised to x over b raised to x. Law number 5, a raised to x and the quantity is raised to y. This is equal to a raised to the product of xy. Law number 6, a raised to 0 equals 1. Property number 2 is a raised to x equals a raised to y if and only if x equals y. There is a restriction that a is not equal to 1. Property number 3, a raised to x equals b raised to x if and only if a equals b. There is a restriction that x is not equal to 0. Let's go now to sample problems. Example 1. Simplify using laws of exponents and write answers using positive exponents only. We have two problems here, A, B. Letter A is 2 raised to 5x minus 1 times 2 raised to 3 minus 2x. So we have here multiplication of exponents with same base. So what we'll do is simply add the exponents. So we have 2 raised to 5x minus 1 plus the other exponent is 3 minus 2x. So we can directly remove the grouping symbol and add corresponding terms. So the 5x and the negative 2x we will combine together. It will be 3x. The negative 1 plus 3 is positive 2. So our final answer is 2 raised to 3x plus 2. For letter B, we have division of exponents with the same base, which is e. So we will subtract the exponents. So we have e raised to 4 minus 3x, then minus the exponent of the denominator 2 minus 5x. In the next step, we will remove the grouping symbol. In the first group, we can directly remove the grouping symbol, but for the second group, we need to change first the sign of the terms inside this grouping symbol. So we have now e raised to 4 minus 3x minus 2 plus 5x. And from here, we can combine similar terms. The 4 and the negative 2, we can combine together. It becomes 2. And the negative 3x plus 5x is positive 2x. So our final answer is e raised to 2 plus 2x. Let's go to example 2. Solve for x. We have two problems here, A, B. Let's begin with A. 4 raised to 5x plus 1 equals 16 raised to 2x minus 1. First, let us check if the bases can be made equal. We can see here in the left side the base is 4, on the right side the base is 16. And we know that this 16 can be rewritten as 4 squared. So it will be like this now. The 16 becomes 4 squared. And the power 2 here, we can multiply with our exponent outside. So the 2 times 2x becomes 4x. 2 times negative 1 becomes negative 2. On this line, we can see that the bases are now equal. And according to property number 2, a raised to x equals a raised to y if and only if x equals y. It means to say, we can copy the exponents 5x plus 1 in here and equate that with the exponent of the right side, 4x minus 2. And from here, we will solve for x. The 4x on the right side, we will transpose on the left. Of course, the sign must be changed. Also, this plus 1, we will transpose on the right side. The sign will be changed. So, we have now 5x minus 4x equals the negative 2 and minus 1. To simplify further, the 5x minus 4x becomes x, and this is equal to negative 2 minus 1 is negative 3. Let's go to problem B. The quantity 2x minus 1 is raised to 5 equals negative 32. I know that this negative 32 can be written as negative 2 raised to power 5. And if I do this, I can observe that the exponent here, which is 5, and the exponent here, which is now 5, are now equal. So according to property number 3, a raised to x equals b raised to x if and only if a equals b. It means to say, we can now copy the bases of the left side and the right side respectively. Thus, 2x minus 1 is now copied here is equal to the negative 2. And from here, we're going to solve for x. The negative 1, we will transpose on the right side. It becomes plus 1. And then we will simplify further. The negative 2 plus 1 is negative 1. We will divide this equation by the coefficient of x, which is 2. So we have now 2x over 2 equals negative 1 over 2. And we will cancel the coefficient of x and the divisor 2. So only x comes down, and this is equal to negative 1 over 2. This is our final answer. Example 3. Solve for x. We have here problems A and B. Let's begin with problem A. 3 raised to x plus 1 equals 9 raised to x minus 1. We can see here that we have different bases. Here is 3, the other is 9. But this 9 we can show as 3 square. So the right side becomes 3 square, that is raised to x minus 1. We can multiply these two with the binomial x minus 1. So the exponent of the right side becomes 2x minus 2. Now we can see that we have the same basis, which is 3. We can use property number 2. So when we have same bases, we can equate the exponents. So the left side becomes x plus 1 equals the right side 2x minus 2. Let us solve now for x. This 2x we transpose to the left, the positive 1 we transpose to the right. So we have x minus 2x equals negative 2 minus 1. X minus 2x is negative x. Negative 2 minus 1 is negative 3. We multiply this equation by -1 so that the x will be positive. So we have x equals positive 3. This is the answer for problem A. What about problem B? 3x, that is squared, equals the square of 2x plus 5. We can see here that we have same exponents. So we can use property number 3. We say that if the exponents are the same, we can equate the bases. So we have 3x equals 2x plus 5. Let us solve now for x. This 2x we transpose to the left. So we have 3x minus 2x equals 5. Then the left side becomes x equals 5. This is the value of x. Example 4. Solve for x. We have two problems. Let's begin with A. That is 2 raised to the power 3x plus 1 equals the square root of 2. On the right side, we write again this radical into fractional exponent. So the square root of 2 becomes 2 raised to the power 1/2. In this equation, we can see that the bases are same, which is 2. So we can equate the exponents. That is property number 2. So we write now 3x plus 1 equals 1/2. Let us solve now for x. The positive 1 we transpose to the right. So we have 1/2 minus 1. And the right side becomes negative 1/2. Let us now divide this equation by the coefficient of x, which is 3. And if we do that, the 3 here cancels out. And the right side becomes negative 1/6. We can see here that it seems that this 3 is multiplied to the denominator 2. So we got here the 6. This is the value for x. Now problem B. 7 raised to x squared equals 7 raised to 2x plus 3. We can see now that the bases are same, which is 7. So we can equate the exponents by property number 2. We write again, we have x squared equals 2x plus 3. Let us solve now for x. The binomial here we transpose to the left side. So we have x squared minus 2x minus 3 equals 0. This is now a quadratic equation. We can solve this by any method. We can solve by factoring or we can use quadratic formula. In this video, let us solve this by factoring. So the factors of x squared minus 2x minus 3 are x minus 3 by x plus 1, then equals 0. Next step is we equate each factor into 0. So we have x minus 3 equals 0, then the x plus 1 equals 0. Let us solve for x respectively. In the first factor equation, the negative 3 we transpose to the right. So we have x equals positive 3. In the second factor equation, this positive 1 we transpose to the right. So we have x equals negative 1. So these are the values for the x, which are 3 and negative 1.